Now, back at the element settlement, let's see where they live. The light metals live up on the top left. The heavy metals live further south. And the non-metals live in this section. The noble houses are on the extreme right. This is part of the noble family: helium, argon, neon. They keep pretty much to themselves.
Help! Someone's stolen my electron!
There are very strict rules, but they don't protect an atom's most prized possession, its outer electrons.
Stop, thief! Come back with that electron!
You'll never catch me, copper!
Nobody's managed to steal any electrons from chlorine. Hers are locked up far too strongly. Still, she's not completely satisfied. Whenever she gets dressed for the Saturday night dance, she puts on 3 layers. First, her underclothes, made up of 2 electrons. Then a bodysuit of 8 electrons. Next is her outer shell of 7 electrons. And here's the problem.
How can I go out like this? There's a gaping hole where one more electron could fit. My outer shell's incomplete and I've no more electrons in my wardrobe. I'll ask my neighbours. They all have beautiful complete shells.
Oh, I was playing polo the other day, and I lost.
Why, hello, Chlorine. How can we help you?
Well, you all have such lovely complete shells. How can I get one like yours?
You need to dance with another atom, get all close and romantic, then rip off its electron.
Some atoms find that attractive.
Oh, don't waste your time here, Chlorine. You're not strong enough to rip an electron off any of us.
Bet I am.
Okay, come and try it. Come on now, a big, strong kiss. See? Not strong enough.
My small sister Florine always gets what she wants.
Indeed, Chlorine and her bigger sisters, Bromine and Iodine, lock Fluorine up before the dance because she's so attractive.
Why am I stuck here all day dissolving the dishes while everyone else is having fun? No one ever sees me and I'm so attractive.
Argon, how will I find a partner for the dance?
We have already advertised for you. It should attract an atom from the other end of town. At the other end of town, the next period begins with the elements 11 to 18. Sodium's inner shells are filled with 2 and then 8 electrons. The 11th electron roams freely over a very large space and is held weakly. It could easily be stolen by an atom looking for an extra electron. Sodium is on the left of the periodic table. It has 3 shells, putting it in the 3rd row. Now the pattern repeats itself in the outer shell. After sodium comes magnesium. Its 2 outer electrons are again paired in the S subshell. Next is aluminium with 3 electrons. When we get to silicon, 2 electrons are paired in the S subshell and 2 are unpaired in the P subshell. Silicon is below carbon, and both atoms have similar properties, with 4 electrons in the outer shell. Everything to the left of carbon and silicon are metals with 1, 2 or 3 electrons in their outer shell. Phosphorus has 5 electrons, 2 paired and 3 unpaired, and is placed in the 5th group. Sulfur, with 6 electrons, appears in the 6th group. Chlorine, like fluorine, has only 1 unpaired electron. Chlorine tries to grab an extra electron, but isn't as attractive as fluorine. This is because chlorine's unpaired electron in the outer shell is further away from the nucleus. All the elements in this group will try to grab an extra electron, but they're less reactive as they get larger. Finally, in argon, the electrons are all paired, and the S and P subshells are full. Argon neither gives nor takes electrons. All the outer shells of elements in this group are complete. These are noble or inert gases and will not react.